Hey guys, these are the notes for subtracting polynomials. They're very similar to adding polynomials, and we still only have two directions here. Our first one is going to be to first distribute. So you always want to distribute first whatever you have outside of your parentheses. And the next thing is to combine like terms. And you always want to combine like terms starting with the highest exponent. Because when we start with the highest exponent, that already leads us into the position to combine like terms and make it in standard form automatically. And we don't have to think about standard form afterwards. So our first example, number 1, we have two sets of parentheses here that are going to be subtracted. Well, just like adding polynomials, we always want to look at the number attached to the front of the parentheses. So for example, this one has a 1. Since there's nothing there, we assume that it is 1. For the next set of parentheses, there's still a 1 here. Okay, so let's look at the first set. If I take 1 and I distribute it to both terms, or all of my terms inside my parentheses, does it change anything? No, it doesn't. So I can actually just drop my parentheses and I have 3x squared plus 5x. Nothing changes. However, over here, if I take negative 1, because there is a negative sign here, if I take negative 1 and I distribute it to both of these terms, does it change anything? Yeah, it actually does. It changes their sign. So, in this case, I do have to distribute. I can't just drop my parentheses here. So I'm going to distribute negative 1. That's going to give me negative 2x squared. And then negative 1 times 7x is going to be negative 7x. So it just changes our signs the other way. So it is important that you don't just get rid of them just because you're like, oh, there's no number there. There is a number there, and the negative does matter. So that's going to be the one that gets you. All right, now we're going to go ahead and combine our like terms. So you always want to start with the highest power. Our highest power here is 2. So we have 3x squared minus 2x squared. That's going to give me a positive x squared, so 1x squared. And then I have 5x, and I can actually have like terms with negative 1x or negative 7x, so those are like terms. That's going to be negative 2x. And that's my final expression here, and it's already in standard form. And if you want to practice, this is actually a second degree binomial because there's two terms and the highest degree is 2. All right, moving on to our second example, we're going to have 3 times x squared minus 7 plus 5x. I'm actually going to move this down because it's in the way of the other one. Minus x squared minus 4. Alright, so just like the other one, you want to examine, can I just drop my parentheses or do I have to distribute? Well, our first step up there says to always distribute first. And here I have a 3 on the outside of my parentheses, so when I distribute to all of my terms, I'm going to multiply by 3. 3 times x squared is 3x squared. 3 times negative 7 is negative 21. And then 3 times 5x is positive 15x. Okay, over here, again, I really do have an imaginary 1 here, so I'm going to actually fill that in. Negative 1 times x squared is negative x squared, or negative 1x squared, whatever you prefer. And then negative 1 times negative 4 is a positive 4. So that 1 is still there, and it does matter. It does matter to change your signs there. All right, so we're going to start with our highest power to combine like terms. That's going to be 3x squared. And then I also have a minus x squared. Those are like terms, because remember, like terms are the same variables and same exponents. 3x squared minus 1x squared is going to be 2x squared. Our next highest exponent is going to be 1, which is just the 15x. I can't combine that with anything else, so that just stays the way it is. And then next I have negative 21 and positive 4. Those are like terms. And then I'm going to have negative 17 there, because negative 21 plus 4 is going to be minus 17. And that is my final expression. This is a second degree trinomial because the highest degree is 2, and it is trinomial because there are 3 terms. All right, moving on to number 3. We have 2 times 8x squared minus 7x to the 4th plus 5x cubed minus 3, forgot the parentheses, minus 3 times 7x cubed minus x to the 4th plus 6x squared. Alright, so make sure we are taking notes. So if you are watching this video, I hope you are taking notes. Okay, we're going to begin. I'm going to look at my first set of parentheses. I have 2 times all of these terms. Again, you're going to distribute the 2 to every term that you see. So 2 times 8x squared is 16x squared. 2 times negative 7x to the 4th is negative 14x to the 4th. 2 times 5x cubed is 10x cubed. Okay. Over here I have negative 3 times 7x cubed. Remember, it is negative, so I have negative 21x cubed. Negative 3 times negative x to the 4th. And if you're wondering, there is a 1 here. It's just an imaginary 1. So if it helps you, you have negative 3 times negative 1, which is positive 3x to the 4th. And then I have negative 3 times 6x squared, which is negative 18x squared. So I have lots of terms, but again, you're always going to start with the highest exponent, which in this case would be 4. Negative 14x to the 4th plus 3x to the 4th is going to give us negative 11x to the 4th. Okay, the next highest exponent is a 3. We have 10x cubed minus 21x cubed, which gives us negative 11x cubed. So we have another 11 coefficient there. And then lastly, we have 16x squared minus 18x squared. That's going to give us negative 6x squared. Oh, just kidding. Negative 2x squared. Counted wrong. All right. And that is our final expression. This would be a 4th degree trinomial because your highest degree is a 4 and you have 3 terms. So this is very similar to adding polynomials. Again, you're still combining like terms like always, and you're still distributing. The only trick here is that there is a negative sign, so it is an extra thing to think about. But that is it for subtracting polynomials.